In this video, I'm going to discuss some of the mathematical expressions. So I have written three claims over here. Let's take a look at this one. So in the first one that I have written, that is this one, I'm saying that summation of xi minus x bar multiplied by y minus y bar is equal to summation of xi minus x bar multiplied by yi. We do have a mathematical proof for this equality, which I'm going to show you in a minute. But before that, notice what I'm trying to say over here. So in the first expression over here, I'm saying that even if you remove this y bar, it won't make a difference. Okay, so the only difference between the left hand side and the right hand side is that the left hand side has this extra y bar, which the right hand side does not have. Okay, and I will show you the proof of this in a minute. Let's take a look at the second equality that I have written over here. The second equality is pretty basic. Basically, I have written this is equal to this. So on the left hand side, I have multiplied xi minus x bar by y minus y bar, and then I have put a summation sign. On the right hand side, I have multiplied y minus y bar with xi minus x bar, and then I have put a summation sign. So it doesn't really matter whether I write xi minus x bar first or y minus y bar first. This is quite logical. Now let's take a look at the third expression that I have. Basically, the left hand side that I have over here is actually this thing only. Okay, so I'm saying that the left hand side that we have, even if I remove this x bar, it won't make a difference. Okay, so if you see the right hand side is the same thing that we have on the left hand side without x bar, right? So what have we learned from here? That if we have x bar and y bar both in a certain expression, and if the expression looks like this, then you can remove any one of this and the equality will still remain. So this expression and this expression that you have over here, both of these are the same expressions, right? So in the first expression, I removed y bar. It did not change anything. The equality is still remaining. In the third expression, I removed x bar. It did not change anything. The equality is still remaining. Now, many students try to use this shortcut again and again. Basically, I have seen students working with this expression and then writing this expression as this by saying that we can remove x bar. Well, you cannot. Similarly, I have seen students doing this mistake that I give them this expression and they say that this expression is equal to this expression because they just removed y bar from the expression. Well, you just cannot remove x bar and y bar from any expression. If you have x bar and y bar both, and if the expression is written in this manner or in this manner, then you can remove any one of them as per your choice or as per your need. However, when you talk about these type of expression, that is this one and this one, you cannot apply that trick over here. You just cannot remove x bar now or y bar from here. Okay, so let me show you some of the mathematical proofs as well. So the first claim that I made is this one. So I said that summation of xi minus x bar multiplied by y minus y bar is equal to summation of xi minus x bar multiplied by yi. Okay, let me quickly show you this. So let's start with the left hand side. So this is the left hand side that we have. Now this is the first bracket. So I'm going to multiply this with this and I'm going to multiply this with this. Okay, so this will become summation xi minus x bar multiplied by yi minus xi minus x bar multiplied by y bar. Okay, so this is what we have on the left hand side. So I'm starting with left hand side and I'm going to show that this is equal to the right hand side. Now if I apply the summation sign on both of these terms, this is the first term and this is the second term, then I'll have summation xi minus x bar multiplied by yi minus summation xi minus x bar y bar. Now see this y bar that you see over here, this can be written outside the summation sign because it does not have any role inside the summation. This y bar is a particular constant. So that means this second expression that you see over here, this can be written as y bar summation xi minus x bar, and the first expression remains as it is, that is this. Okay, now in the second expression we have y bar multiplied by this and this is actually equal to 0. So summation of xi minus x bar is actually 0 by a statistical property. It is the sum of deviations from mean, and there is a statistical property which says that the sum of deviations from mean is always equal to 0. I can also show you this. So let me create some space for that. So I'm saying that this term that you have over here, this is equal to 0. And think of it in this manner, that summation of xi minus x bar, this can be written as summation of xi minus summation of x bar, right? So I've just distributed the summation sign. Now summation of xi remains summation of xi, but summation of x bar becomes nx bar. The reason is that x bar is a particular constant, and if you sum a constant n times, then you can just write n times that particular constant. Now we know that x bar is equal to summation of xi divided by n. Okay, this is how the sample mean is defined. This implies that nx bar is equal to summation of xi. That means these two are equal. So summation of xi is actually equal to nx bar, and if you subtract these two, you will get 0. Okay, so this term is 0. That means you're multiplying y bar by 0. That means the second term goes away and you're just left with summation of xi minus x bar multiplied by yi, which is actually the right hand side. And this is what I was trying to prove you, that if you start with this expression, okay, then you can go from here to here. Okay, similarly I can show you that this is not equal to summation of xi multiplied by yi. This is quite a simple task. So once again, let me start with the left hand side. The left hand side is summation of xi minus x bar multiplied by yi, and there are two terms, so let's multiply these two terms. So it will become summation of capital xi yi minus x bar yi, and this is equal to summation of xi yi minus x bar summation yi, which is definitely not equal to summation of xi yi, right? So this is what I was trying to explain you, because when you do the formula for beta 2 hat, you will have to work with these mathematical expressions, and I have seen many students making mistakes in these mathematical expressions. So you should know that you can go from here to here by removing this y bar if you want to, but you cannot then remove the x bar and go from here to here. That is something that you cannot do. Okay, so be careful with these mathematical expressions as well.